Right now I'm going to show you some bearing faults to give you a good idea. This is a SKF. It is a angular contact, and if you get a good look at it, you can see these vertical lines from shaft current. This particular motor wasn't being run on a VFD. It was straight across line. It was inherent to the design of the motor. We re-insulated the bearing mount, installed the shaft grounding brush assembly into the lower bearing cap, and took care of the problem. This is a spherical roller that you can see has the same problem. It has vertical lines from shaft currents running all the way around the outside of the bearing. If you were using a bearing analyzer, you would see a floor trash level way out in the middle of the spectrum if you're somewhere around 1500 hertz. You can see all the shaft current problems showing up. Some of the methods for being able to repair a problem when you have a shaft current issue is you can install an inexpensive method which utilizes a silver graphite brush material that's real low resistivity and very high conductivity, and it actually runs at the bottom of the seal area of a bearing cap or of a housing and touches the shaft. Now these are good for average motors, even up to maybe 500-600 horsepower. If the current gets too great, one, it can actually try to melt the pigtail. It'll still make contact with the brush in the housing of the brush holder itself. So this is one way that's a pretty good way to do it. It's not bad, but there's a much better way to do it. And that's by utilizing a shaft grounding brush by Aegis. This particular one is for a 20 megawatt generator unit. You can see it's got carbon fiber that's all the way around that makes contact with the shaft surface. These are good for approximately 100,000 hours of use. So they've got a long longevity and they work very well. They can be made out of stainless steel or aluminum like this one in this case. Several other constructions depending on if you have problems with chemicals or an atmosphere area problem. The Aegis brush design can be utilized inside of a motor. If we're going to use this process in a vertical motor, this is the one I would recommend, where you're actually insulating the actual bearing carrier for the thrust bearings here, and then installing the Aegis grounding brush assembly inside the bottom of the bearing cap at the bottom of the motor, shunting any current or voltage past the bearing before it gets to the lower bearing by insulating that and having it flow through down to the framework that way. This works real well. It eliminates about 90% of the currents. This is impressive. This is a coil that was put into a motor that was 1800 RPM and then run at 2300 RPM. You can see it's nice and flat on the one side. The best part about that is this is the same bearing in an FAG. This is the coil version of the same 29434. So if you look at them, there's a considerable difference in the size of the two rollers, even though that is two rollers welded together. This one was actually running, and the last person who repaired it tried to stop oil leaking by plugging the port that allows the oil to get to the bearing. I'm going to show you an internal race next. That's on a vertical motor. This side was towards the actual rotor itself, so it would be sitting vertically like this. And you can see where the spalding marks are all the way to one side, as well as a lot of them line up with what looks like burnelling. And the burnelling meaning that it has lines from transporting or shock pack hitting it, dropping it on loading it onto the pump base, etc. And then these craters starting after it already had those little dings in it. But the most important part is that this was run without a pump on it. It allowed this bearing to pull up from the spring tension to the spherical roller and cause all the damage to the bottom end of the inside of the race instead of in the center. That pretty much concludes our bearings for right now. Thank you.